Hello guys, welcome back. In this video, we're going to talk about the grid agent. You guys are going to observe the aggressiveness of this agent for rewards. The plan for this video is as follows. 1. Expose the drawbacks of the random agent. 2. Assimilate the design of the grid strategy. And 3. Implement the grid agent in Python. It sounds like a plan. Let's start discussing the drawbacks of the random agent. First of all, take a look at this bar graph over here. We have the name of the agents and their score performance in the horizontal bars. Notice that the omniscient agent has the highest score. As we have discussed previously, the omniscient agent reaches the maximum rewards, around 800, which is considered the top score. We can see the performance of the random agent right below. Its reward is around 550, very low compared to the top score. It happens because the random agent spends the entire time in the exploration phase, and it doesn't update its strategy based on the learning generated from the trials. During the exploration, it sometimes picks up the best bandit machine, sometimes it chooses the poor bandit machine. It makes the score performance very low. Also, we can see the performance score from other agents. From now, we can call them using a generic name like Agent 1, Agent 2, and so on. We will explore them in the next sections. In summary, we can draw 3 drawbacks from this analysis. First, the random agent provides a low reward score. Second, it doesn't use knowledge from trials to improve its strategy. And third, it stays full-time in the exploration phase. These results are related to the reward score. We still have other important results to evaluate. The estimated value of the reward probability of each bandit machine. Honestly, this is surprisingly very good, even though the reward score is very low. These results are around 30% and 80% for bandit machine 1 and 2 respectively. They are practically identical to the parameters that we have set for the experiment. It's definitely an advantage of this agent. In conclusion, the random agent provides a very good estimated values of the reward probability for the bandit machines. In contrast, it presents a very low score performance. Now, let's explore a new AI agent called Grid Agent and see if it can help us to improve these results so far. The strategy of this Grid Agent is as follows. In the first trials, the Grid Agent pulls the arm from all bandit machines, one by one, and observes the amount of reward that comes out from each bandit machine. Then, it selects the bandit machine that returns the highest reward and pulls its lever for the rest of the trials until the end of the experiment. As you guys can realize, this strategy doesn't encourage too much exploration. It spends a very short time to figure out which bandit machine returns the highest score, shift to the exploitation mode, and use this information to pull the lever from the bandit machine pointed as the most profitable one early in the first trials. At the first glance, you might not feel that it's a good strategy because the agent could have spent more time in exploration mode before shift to the exploitation phase. However, if I was in your shoes, I wouldn't take any conclusion too early before we implement this agent and see its performance. Talking about implementation,